Welcome to qnawire.
Right. This problem just got a little trick, but we're told that the frictional force is 25% of the weight of the skater. Um, Now weight is just the mass times acceleration due to gravity. That's what's meant by weight. Um, so now when we look at what the actual equation for the frictional force is, frictional force is equal to mu times the normal force. Um, and when you look at the normal force for a flat surface, it is this mg over here. So if this force is 25% the weight of the skater, that means that this mu has to equal to 0.25. That's really the tricky part of the problem. After that, it's just conservation of energy, right? So, um, yeah, the kinetic energy the skater has um, at I guess we'll say this is before, and then plus the work that goes into the skater by the ice equal to the kinetic energy of the skater after, right? Pretty simple conservation of energy. Cool. We know that, oh, there's another cool thing here too. Okay, so we know that when we substitute in equations for kinetic energy and work here, let's do this. Right, so when we substitute in those equations, we see that each term has an m in it, right? We can actually cancel out the masses, and it actually doesn't matter how much the skater weighed. I think that's kind of cool. Now, the only thing that isn't clear about this equation is where we got this term from, right? This is the work term, and this is the force you put on something times the distance you push it, right? So just W equals FD. There. So now we want the distance, right? So how long is the ice? Basically, we have this equation in terms of things that we know, the before and after velocity, and the acceleration of gravity, and mu, which we just found above. Now we can use it to calculate d, and then once we do that, we should get a value of d. Right, so if you get that equation for d, and then we put in the variables that you get 1.28 meters. So that's the length of that rough patch of ice. Seems to me like if you were going along and you went from, 3 meters per second to 1.65 meters per second in only 1.28 meters, it seems like you'd probably trip and fall over. So, it's quite a reduction.